The threat actor used OSINT reconnaissance to map our attack surface, exploited the vulnerability to gain initial access, then used lateral movement and privilege escalation before exfiltrating PII and establishing persistence. If you don't understand this sentence, and if you want to understand more about how people in cybersecurity talk, then this is the video for you. Welcome back to Think Design Work Smart. I'm Alex Bolboaca and I'm coming at you from the Mozaic Works studio. And today I want to explain some of the common terms used in cybersecurity. The problem with cybersecurity right now is that there are two different worlds who deal with it. There's the cybersecurity experts world, where people are trained into things like penetration testing and finding out bugs and figuring out how to break systems, how to break into systems. And on the other hand, we have developers, the development world, people who build these systems. And these two worlds should cooperate. Everybody agrees, if you ask them, that security needs to start from the very beginning. It needs to start with analysis, through architecture, through implementation, through testing, through deployment, infrastructure, and it ends, well, it doesn't end, but let's say one of the final steps is verifying that we don't have any security vulnerabilities that we are not aware of. But until we get there, what we need is a lot of attention on the whole chain. So how can we do that if we don't speak the same language? And that's the reality. The cybersecurity experts speak their own language that sounds like the sentence I just said. Whereas developers, they think more about, writing code and installing stuff and making things work. And as long as we don't speak the same language, we have a problem. So let's unpack this sentence. This is what I'm going to do in this video. First of all, let's reread the first part. The threat actor used OSINT reconnaissance. So threat actor, you can replace that with hacker. That's an easier word to remember and to use. The second part would be OSINT reconnaissance. What is OSINT reconnaissance? Actually, what is OSINT? What is reconnaissance? Reconnaissance is the act of a potential attacker to map your system, to gather information from all available sources about your organization and about your product. So assume you are protecting web application. What are the important things related to that web application that attackers would like to know? Well, they would like to know two types of information. One is organizational and the other one is technical. On the organizational side, they would like to know who are the managers, who is in the team, what are some public areas where maybe you publish stuff. Do you have GitHub repositories? Do you have a company website? Do you have DNS records? And so on. A lot of different things. On the technical side, they would like to know stuff like the website version, the web server version, the technology that you use, the public APIs and their maps, any libraries that you might use, any external services that you might use. the tech stack. And all of these are important because depending on these, attackers can pick from various methods of attempting to breach into the system. So something as simple as this web app is running on Nginx version 11, whatever, I don't know the Nginx versions. But this is an important information because maybe that specific version of Nginx has a specific vulnerability they can try to exploit. So because of this, what attackers would do is they would look for two types of informations. Some of it that can be searched without touching the website, stuff that is in Google indexes, for example, or published on social media, and they would search for that. And on the other hand, they will search for information about the tech stack and so on, which often is information that they need to visit the site in order to obtain, unless you can figure that out from the team structure. Because if you know who is working where, then you can look in their LinkedIn profile. You can see what experience they have with what technologies, and that's a pretty good guess. So open source intelligence means, which is OSINT, O-S-I-N-T, OSINT, is gathering information from public available sources. So in other words, OSINT reconnaissance just means searching the web for anything related to your organization and your product. That's it. So let's translate. The hacker searched the internet for information about your organization and found enough information to, and the phrase continues, map our attack surface. So once they know what, in general, what your web app is doing, now the attack surface is all the points where an attacker can try to interact with your system. This can be public endpoints, login forms, APIs, emails, because social engineering is a thing, phishing is a thing, sending a link through email that seems to come from your manager, and then you click on that link and it takes you to a vulnerable website where you enter your GitHub password. Might be a thing. So that's definitely something they would look at. And this is the attack surface. Everything where every point related to your application, every protocol that an attacker can use in order to try to get into, to breach into your system. So this is pretty clear. Now they are looking for a way in, which would be the next step. So the next step is exploit a vulnerability. Exploit a vulnerability, well, what is a vulnerability? You have a weakness in your system. Maybe you have an endpoint that has a hard-coded password or an easily guessable password. Maybe you posted by mistake the secret key to GitHub, and through searching the Google index, the attacker managed to get that secret key and to call a specific endpoint, maybe a developer endpoint. Maybe you left a monitoring endpoint uh, unprotected, and somebody can hook into it and gather data related to monitoring, which could give them additional information about the internal structure of your application. So a vulnerability can be a lot of things. It can be a misconfiguration, it can be an exposed port, it can be a service or a protocol that is left open and that an attacker can breach because it is vulnerable. And an exploit is using that weakness to gain access. What an exploit could be, it could be something manual, like maybe the hacker is typing something, is building a string to do a SQL injection or a command injection or a cross-site scripting attack. Or it can be something that is automated because it's about a known vulnerability to an existing protocol, and then all they need to do is to download the app that they can run to attack that specific vulnerability, and they use it. Okay? So now they are in. Let's assume this works, and they entered into the system. The next step and the next part of the sentence is, let's go back to it. The threat actor use OSINT reconnaissance to map our attack surface, exploiting a vulnerability to gain initial access. So this is where we are right now. And by now, we understand roughly half of this sentence. Then use lateral movement. What is lateral movement? Well, so maybe they managed to get a foothold into your system. So maybe they ran command injection that gave them access to a local computer, right? But then the next thing, or just learned about that SSH is enabled, but now it would be nice to actually connect through SSH to that computer so that they can actually run additional commands. Or maybe they just got access to the server where the application is running, but what they would really like is either authentication data or data from the database. So then the next step is to figure out how to run that specific command or a set of commands that gives them access to the database. Maybe look at the configuration file that has the database string and connect to the database in order to extract some data, right? So, or maybe they want to, or they can try to do something else, which is called privilege escalation. So let's talk about that, which would be the next part of our sentence. Privilege escalation means, let's say your web app runs with a normal user and they gain access to that server, but all the commands they can run with that normal user. What they would really want is to run commands as root or as an admin. So that would be what privilege escalation is, gaining higher level permissions than originally obtained. Now, there are, of course, a lot of variations to all this. Another variation would be maybe they can log in to your web application as a user, as an existing user. Let's say you have SQL injection and they managed to log in using SQL injection as an existing user, but that is a non-admin user. So now what they would really like to do is to log in as an admin user. How could you do that? Well, one way would be to try to change, to do a URL enumeration attack where you change, let's say if you have /user/1000 and this is the user they managed to log in with, they could try to go to /users/1 and hope that this gives them access to the admin, which is likely to be ID 1. And of course, there's a lot of trial here, right? So, but these attacks can be automated. I'm explaining them slowly, but in reality, you'd run scripts and tools to make these things for you, and to give you more information. So this is privilege escalation. And now let's talk about the final things. So if we go back to our sentence, the threat actor used OSINT reconnaissance to map our attack surface, exploited the vulnerability to gain initial access, then used lateral movement and privilege escalation. So we got here, basically what we are saying until now is that a hacker searched the internet for information about your product, your organization, found enough information to understand what they can attack, found a breach, got into the breach, and then managed to expand the breach in order to be seen by the system as an administrator. Okay, so they gain administrator rights. And now we have the last part of the sentence, which is before exfiltrating PII and establishing persistence. What are these things? What do they mean? Well, let's talk about exfiltration. What does exfiltration mean? Well, it's just copying the data. That's what it is. Exfiltration, like all the terms that we have been using until now, these are military terms or military informed terms, right? Intelligence, reconnaissance, exfiltration, infiltration. These are really coming from that area. And they sound really cool to people in cybersecurity. But honestly, I believe for developers, and I think in general, it would be better if we could use some more common terms. And exfiltration is the funniest to me because that is really copying data out, right? So your attacker managed to get to the point where they can access some data and they are copying the data out of the system. How would they do that? Well, they could download it, they could send it to a server that they control, they could send it piecemeal, like split it into packets and stream it to various places, let's say to S3 buckets. They could send DNS requests to specific domains that they control containing these data, and then when they look at the log of the DNS requests for that particular domain, they can extract and rebuild that data. That depends a lot on the on your system, on what it allows in terms of outside calls and what they managed to do. So did they manage to have something in place that connects to an outside system and copies data there, or they need to be more creative about extracting the data. But when you hear exfiltration, this is what it means, copying the data. And the next part of this is PII. What is PII? PII means personally identifiable information. So any information about your users that can identify a person. This includes names, emails, addresses. That's typically it. Could be other things as well. So, and this is different from, let's say, financial information, which would be credit card numbers, bank account numbers, other things like that. And finally, the last thing that the sentence says is, and they establish persistence. What does this mean? Maintaining access for future use. So everything that we talked about until now could be done through an attack that takes them to a place where they can extract the data, but in order to go back into your system, what they need to do is to redo the attack. And this is problematic for a hacker because things can change. Maybe you update your systems, maybe you update your APIs, right? So it would be really nice from a hacker's perspective if they could somehow put something in place so that they can come back to your server from time to time and see what you have done and if you have any more goodies coming. So for example, a common thing here is to create a backdoor. Maybe install some kind of malware that scans, wakes up from time to time and connects to an external server and copies data there. Or just allows them to connect to this server when they want to try some more things and so on. Or they could install some kind of keylogger that sends data to their own servers. And in that way, they can maybe later on gain access as a root user on that particular system. And this is persistence. So let's now talk about the phrase again. The threat actor used OSINT reconnaissance to map our attack surface, exploited the vulnerability to gain initial access, then used lateral movement and privilege escalation before exfiltrating PII and establishing persistence. So let's recap what this is saying. A hacker searched the internet for information about your product in your organization, found enough information to figure out what they can attack, and found a breach, managed to get into that breach, then managed to expand their access and gain more privileges, and copied personal data from your database to their own servers. After that, they manage to install things that allows them to return to your servers. And this is what this phrase means. If you understand this phrase, you'll probably understand about 80% of security talks. It's a little bit more complicated, but at least this gives you a really good start on understanding a lot more about what security experts are talking about. And if you're interested in this topic, maybe next time we'll do a little bit more about how we can stop this chain of attack, or how what other terms are not known to developers and should be known. In this case, more on the defense side, because right now we talked about the terms that you'd find when describing an attack. So what do you think about all this? Did you find this useful? Is it worth making videos like this? Let us know in the comments. Give us a like, give us a subscribe, share, tell other people about these videos. By the way, as we noticed, we don't have sponsors, we don't have any promotions in these videos other than the occasional talks about our own courses if they fit with a specific topic. So, and in this case we actually have secure coding and secure coding for embedded systems where you can learn and practice more of these things. But what this means is that we really do this as a way to educate developers and to bring light to interesting topics that we find very important. So leave us a like, share, subscribe to the channel, invite other people to subscribe, because it would be really nice to get to 1,000 subscribers in maybe by the end of the year, although probably sometimes next year. Thank you kindly for the view, and until next time, remember to think, design, and work smart. See you next Saturday.